In case you need a little more explanation about factoring binomial, we have different types of binomials that factor. Difference of squares, like x squared minus 4. X squared is x times x, and 4 is 2 times 2. And the difference means it's minus. We know that this is x plus 2x minus 2. We have all sorts of difference of squares that you've seen before. For instance, if we have 100x squared minus, I don't know, 9y to the fourth. That is a difference of square also, because we have 10x and 10x and 3y to the second. So it would be the same thing, 10x plus minus 3y to the second, 10x plus 3y to the second. Sorry, that's ugly, but that's the way it is. Anytime you have a perfect square minus a perfect square, you can split it up into what's the simple formula, right? A plus b, a minus b. It always works out that way because the middle terms add up to 0. I think we've had that one before. Then we had in the lesson 4.4, you had difference of cubes and sums of cubes. They're real similar. And there was a formula for these too. If you had two perfect cubes, then you had a minus b, a squared plus ab plus b squared. That was one of the formulas. You could have learned it that way. So for instance, if I gave you something like x cubed minus 1,000, you'd say, well, first identify what's being cubed. Well, x is being cubed, and 10 is being cubed. 10 times 10 times 10 is 1,000. That's my a and b. A squared is x squared. B squared is 100. And a times b would be x times 10, which is 10x. So if we're trying to factor a binomial that's a difference of two cubes, like this one, it would be x minus 10 times x squared plus x plus 100. Another way that I showed for doing that same type of problem, you'd still have to know that x and minus 10 were what were being cubed. But in this situation, you work backwards and say, okay, well, x times x squared is x to the third, and negative 10 times 100 is 1,000. Of course, that's the same thing as what we just got here, right? And then we know that the diagonals of these kind of boxes, if you've done them as you've done them before, add up to 0 because there's nothing else there. There's no middle terms. So this one is negative 10x squared because you do negative multiplying the outside. So this one has to be positive 10x squared. Well, if it's x times something equals 10x squared, then this top number is 10x. X times 10x is equal to 10x squared. And of course, that's what we got here, x squared plus 10x plus 100. So I don't care how you do it, but you need to know this first part here about what's being cubed. So recognizing perfect cubed is kind of important, being able to do this kind of problem. Of course, the other type that we had is really the same thing, and that would be sums of cubes. And the sums of cubes has almost the same formula, but the plus sign or the minus sign is second, not first. Before we had these two signs switch places. On these problems, you only have one minus sign, and that's what gets rid of all the middle terms. If you have one minus sign, it switches places when you have a sum of cubes. So for instance, if I had some kind of sum of cubes, like for instance, z to the sixth plus some other number, like 1. How about 1? Well, 1's not too interesting, but get the idea. Well, what's being cubed is z squared, and 1 times 1 times 1 is 1. So there we go, z squared plus 1, and then we would have z to the fourth, because it's squared, minus 1 times z squared, that's a times b, plus 1. And there you go. There you have it. Sometimes there will be a problem where you can continue going and continue factoring. This trinomial will never factor, but sometimes this thing in front will. Now, z squared plus 1 will not factor because sums of cubes are not one of the three types of binomials that factor. But z squared plus 1, if z squared minus 1 would have factored to z plus 1, z minus 1. So that's about trinomials, or the binomials that factor. The other thing to know about this lesson was that sometimes you have a greatest common factor plugging things up. So for instance, if we had a problem that had 3x to the fourth y squared z to z or whatever, and we could have minus, I'm just making it up, so it's I'm going to try to make sure that it works out right, about 81 x y to the fifth z. I would first look for a greatest common factor between the two terms and then factor that out and then see what's left and see if it's a binomial that factors. Well, of course, this one, because I just made it to do that, right? 3 goes into 81. So we can say there's a 3 that's coming out of that thing. And there is at least one x in each of these terms, so I can take one of the x's out. There's at least 2 y's, so I can take out 2 y's, and there's just a single z in each one. So I'm going to reduce this thing by dividing out a 3, an x, a y squared, and a z. So on the first problem, I see the 3 and y squared and z are all gone, and one of the x's, so I'm going to be left with x cubed. Big surprise that it's going to be a perfect cube, right? 3 goes into 81 27 times when you divide. The x is gone because we're taking one of those away. 2 of the y's, so I'm left with y to the third, and the z is gone. So lo and behold, we have a difference of cubes left over that we can just go ahead and whichever method you're using for factoring the difference of cubes. I'll do it this way, 3xy plus 9y squared, because I had to do y squared. All right, 3y times 3y is 9y squared. So those are most of the examples. The last type of thing we did in the lesson was to factor something with 4 terms. I'd suggest that you go back to the notes for this section if you want to go through that stuff. All right, that should help with 442 and 445.